the H2SO4 or ammonia or any other organics which are emitted as a precursor gases, and then they undergo the gas to particle conversion process, and then these are in the ultrafine mode, that is 0.01 micrometer, and then they grow in size due to the condensation and coagulation and becomes a fine mode or an accumulation mode, and these are in the range of 0.1 to 1 micrometer, and then these act as a cloud condensation nuclei. That is, a seed will be aerosol, and on it water is deposited, and it forms an uh, cloud condensation nuclei
Hello?
and clouds. And these within the clouds, the aerosols are now removed by
Please
scavenging and
guys
modifying
subscribe to
the
our channel
evaporation process.
and stay connected
Now,
for such
the
video.
larger particle, that is a coarser, or sometimes we called as a giant particles, that is whose sizes are greater than 1 micrometer. They are directly emitted from the Earth's surface by the mechanical process, such as the dust, sea spray, or the volcanoes, or the pollen grains, etc. And they get into the atmosphere, and due to the gravity, because they are larger in size, due to gravity, they have a dry deposition. They come back to the surface or to the wet deposition by the rainfall. Now the lifetime, now we see that in the second lifetime of these are different, because in the aerosols which are in the troposphere, they have a very less lifetime, within a day or within a few weeks. But when these aerosols get into the higher layer of the atmosphere, for example in the higher tropospheric or in the stratospheric layer, so they cause a problem because they stay there for long time and years to come, and they create, they interact with the from the sun, and they pose the environmental concern. Uh, Also, the physical size, that is the size of the particles and the shape of the particles, is based on formation process, from where they are creating or they are forming. While the production source determines the chemical composition of these particles. Now, if we see the difference of the aerosols, so in the urban type of aerosol, where in the cities where there is a different environment. So the aerosols are emitted particularly from the fossil fuel, the biofuels or the biomass burning, and they converted to the gas to particle conversion. And the differentiation is that these particles are very fine in nature, the urban aerosols, and the if you see the number of aerosols in the atmosphere in the finer range, that is less than 1 micrometer, are high in number than the coarser or the larger size of the particles. Now, in the second figure, you see this is the urban aerosol, that is the fine, that is the size fine particles, that is whose sizes are less than 1 micrometer, are high in number than the larger particles. If you see larger sizes, that is larger particles, are more in number than the fine particles. So that's a basic difference, because dust or
अच्छा
sea
हमको देखते
salt,
हैं वीडियो की
they
ओर जाती
are
है
natural aerosols,
वो
and their sizes, particle sizes, are larger than the fine particles. But urban aerosols, they are particularly more dominated in the finer size of the particles. Now, when we talk about the background or the natural aerosols, as I said, the sources, for example, the sea salt, that is the sea spray aerosol. Then dust, we say, that is the second dominant aerosol component, mainly from the desert or the semi-arid regions. Of course, the sulfate aerosols, that are also natural aerosols, that are emitted from the volcanoes, particularly because that ends going into higher layer of the atmosphere. As I said, it goes beyond the tropospheric height in the stratosphere and stays for a long time. Uh, then, for example, here one just example, like there was a volcano in 1991, June 1991, in Philippines
Isco.
known as the
Isco.
Pinatabo, and it had infected or impacted a larger region because the aerosols went in the stratosphere and stayed for a long time, and it impacted not only the Earth radiation budget but also the temperature, tropospheric temperature as well as the stratospheric temperature. So the problem is that it injects
Guys,
large
subscribe कर देना
amount
channel के
of
लिए please.
the
और you can now
gas
study here
which composed of
natural
the
background aerosol.
particularly the sulfuric SO2 gas, sulfur dioxide, which is converted to gas to particle conversion. That is, it becomes
This
sulfate,
is the course which
and
is
then around
I am sharing
50
to you all
megatons it has
for
impacted around
IIRS Dehradun.
in that is injected in the atmosphere, and it went straight to the stratosphere. And the study says that the stratospheric aerosol optical depth, that is the influence of or the impact of the aerosol has increased, that the pollution has increased because
नहीं
when it goes in the stratosphere there is a photochemical reactions, and then because in stratosphere there is an ozone, and it destroys the ozone, so then there is a depletion, there was a depletion in the ozone, and also it has impacted to increase the temperature of the stratosphere by around zero point 0.1 degree to point 0.1 to zero point 0.2 degrees centigrade. And recently there was a volcano from Ethiopia, and in the November last month, and it has also injected approximately zero point 0.2 megatons of sulfur dioxide in the atmosphere, and these not only impacts the troposphere but also when it goes in the upper layer it impacts for longer duration. Now the another question arises that why when we say that particular matter 2.5 or particular matter 10, so why the size matters? So why this size is important to study, and what is a concern? Now I have divided like toxicity. That is, for example, if you see the figure, in this figure we say that this is NOPL. Now when this is respiratory tract. So this is a nasoporo pharyngo laryngo region, that is NOPL. We say from that is no, and then the trachobronchital region, that is T short me, that is from the throat to the lung diaphragm. And these two regions, if you see, because when we inhale, so all the particles goes from nostrils to your throat and then to the lungs and then finally goes to the tissues and to the brain, is almost 80 to 100% as compared to your larger particles. So larger particle, the efficiency is around 60 to 80%, but the finer particles is more than 80%, sometimes 100%. What it means? It means the particle size is less than 2.5, that is fine particles. When we inhale, when they present in the atmosphere in larger quantity,
पढ़ते भी जाओ.
and when we inhale,
Guys,
so
सब्सक्राइब करते जाना
these
चैनल के लिए.
particles get inside our lungs, diaphragm, and tissues, and then they are dissolved in the blood streams and go to the whole of body. And as I said, the particular matter is a complex mixture. So the core or the shell can be of different materials. For example, it can be of carbonous, it can be silica, it can be nitrate, it can be sulfate, it can be complex mixture. And depending on that, the poisonous material goes inside the body and it creates a particles with the electromagnetic radiation, that is the light scattering. So we can see that in the visible range, the 550 nanometer, it has a very high efficiency of interacting, and it is very efficient in interacting with the electromagnetic radiation. So it scatters, it absorbs, and it changes the earth radiation balance. So it is very important to study the optics of it. Now, when we also the similar thing, that when we see the settling velocity, that is what is the efficiency of the settling of these particles from large particles to fine particles, we can see that the fine particles has around 1000 to 10,000 times more efficient to settle than the larger particles. And of course, due to the, as you know, the surface reaction, because the fine particles, more is the surface and more will be the area for interaction with the light and other things. So the smaller particles have a greater surface area and the interaction will be more. Now, as I said, same thing
sizes
which I
for
repeated
PM
in the last
2.0.
slide, that when we inhale, that is the total particles I discuss here, that is around 40 or 50 micrometer particles. And then when
Definitely, they are
inhale,
40 and
and then
50 micrometer.
thoracic particles which are in the range of that is 10 micrometer. And then when it goes aerosol, they are traveling from one region. The sources are from one region, but it travels to thousands of kilometers and settle and create a problem to other region as well. For example, the North Africa region, Sahara region, there is a vast amount of dust flowing from the west, is thousands of kilometers to the South Asia and Southeast Asia. And in fact, there are other regions as well which are the sources, but the impact as around the whole of world in other continents as well. Now, when we say the anthropogenic, because different regions have the predominantly the activities are different. For example, in the Europe, most of the industry transportation is in the diesel and gasoline sectors. So the particles are of different nature. That is a particulate matter. The seed, that is the core or the shell, is of different nature as compared to the Africa, where the predominantly the biomass burning is the source because of the fuel wood, or due to the anthropogenic activity. The biomass burning, that is the incomplete combustion or the complete combustion, creates carbonous type of aerosols. So they are dominant there. In the northern Africa, there is a dust that is a different material, different cores. And in the South Asia and the Southeast Asia also, there are different activities going on, predominantly different activities. So the nature of the aerosols or the chemical composition of aerosol, be it of similar size, the chemical composition will be of different. Now, when we talk about the properties of aerosol, we classify broadly like physical, optical, chemical, and radiative. So we discuss physical, that is the size, the shape, and all that, and as I said, size, that is PM10, PM2.5, or we can say as ultra fine, fine, or large particles. And one more property of the physical is importantly is the refractive index. Now, why we should understand the refractive index? Because this refractive index will tell or give an idea of the type, the nature of the aerosol. That is, whether the aerosol will have a dominant of scattering nature or the absorbing in nature. For example, this is a real, this is mathematically denoted by n plus ik, where the real number is your scattering and imaginary number is your absorption. For example, if you see water, NaCl, that is sea salt, because sea salt, that is sulfate aerosol. So these are naturally released aerosol, and these are predominantly scattering in nature. Larger number scattering in nature. But if you see the black carbon or soot, sometimes we say these are mostly emitted from the anthropogenic activities. You see that the imagery, that is this number, is also high. It means the predominantly it is absorbing, but it will have a small nature of the absorbing, of the scattering in nature, but also it is an absorbing in nature. So this will help to understand the nature of the particle. So for your information, you know what about the scattering and absorption. I need not explain it again. Scattering will conserve the total amount of energy, but the direction will change. But on the contrary, absorption, that is, it will remove the energy and it will re-emit direction and re-emit in another energy form. And there will be a word of extension, that is the attenuation, which composed of the together, that is scattering and absorption together, is known as extension. uh, Now coming to the optical property, that is optical means the interaction of the particle with the electromagnetic radiation. Now this is optical depth. There is aerosol optical depth. That is, uh, it is the what is the extension, that is what is the amount of the scattering and absorption by different sizes of particles at different altitudes. How much is that cumulative effect? What is that effect? That is how much attenuation is given by different particles at different altitude range, is telling about the optical depth. Now, what it means, it in other words, it is also said that it is the amount of radiation that is scattered, that or sent back in the atmosphere before it reaches the Earth's surface. Uh, for example, if I say AOD is equal to AOD is 0.2, if it is 0.2, it means it is a clean type of atmosphere, that is the less or very few atmospheric or few aerosol particles are present, so that is less amount of scattering and absorption happens, so it is fairly clean. When I say AOD is 0.6, so it means a fairly good amount of aerosol particles are present. So the it is the electromagnetic radiation is being scattered and absorbed, and it means more extension is happening. It means it is a polluted kind of thing. And if I say it is 1.2, it means very heavy polluted event is happening, and very severe pollution is happening over that area. For example, uh, this is in the South Asia and Southeast Asia. If you see bigger region, aerosol optical depth, here you see that the darker colors are mentioning that the more aerosol particles are present, more extension, it means more pollution. So if you see the North India, Indo-Gangetic Plain, if you see the north or eastern part of China, if you see the southeast countries, many regions, there are some high spots of pollution, or the more of high concentration of aerosols. And if you associate with this some of the activities, for example, there is a particular period of time, there is a fire, there is biomass burning, maybe forest fire, or maybe anthropogenic fires, and maybe there may be some industrial activities going on, so that also we can distinguish. And on the contrary, there can be some natural sources. For example, there is a dust event. For example, here the northern Tibet area, there is a dust storm which is natural. But if you see the fire activity, there is no fire activity. But this can be associated like this high pollution is due to the natural event. That may be dust, maybe dust. If you see the absorbing, now you differentiate from the absorbing nature. Now here the absorbing or the black carbon which is absorbing in nature will tell you on the only on the anthropogenic part, that anthropogenic. Here we don't see the dust storms or the natural storms. So like that we can understand using the different properties of the aerosol how different mechanisms or different events are happening, and what is the source for it. So this is also in detail of that same figure. Now, the another optical property, that is the scattering phase function. Now, this the aerosol scattering phase function describes the angular distribution of the scattered light. That is how much light is scattered and in which direction it is. Now, why do we know? Why do we want to reveal it? Because this will help to reveal about the particle size, the shape, whether it is a spherical or non-spherical, and also the absorption nature of absorption or the scattering nature, that is refractive index. Another that is the property, optical property, is the single scattering albedo. You very well know about the albedo. Albedo, albedo is the how much light is scattered as compared to your total incident light. So the it gives the how much light is scattered as compared to this extinction. As I said, extinction is how much amount is total received, that is scattering and absorption. So if the single scattering albedo is close to 1, it means it is more of scattering in nature, and if the value is around 0 or less value, it means it is absorption in nature. For example, I have listed here, that is, if suppose it's dust, as you know, there is a natural aerosol, so the single scattering albedo is around 1, so it means this is the scattering in nature, as compared to your black carbon, which is less value, that is close to 0, and lower value, so it means it has a absorbing in nature. So that also we can estimate through different optical properties, one property or a combination of one or more properties. For example, here uh, this is typical the different seasons, winter, pre-monsoon, monsoon and post-monsoon, and these are some of the parameters, aerosol optical depth as I discussed. So if you see the winter season, because of the fog and other things and the other anthropogenic activity and the different due to meteorological conditions and the geography, the more of the aerosols are trapped in this region, and we see the high dense of the pollution, that is more of the number of aerosol particles as compared to your pre-monsoon and monsoon region. When we see the single scattering albedo, that is, as I said, single scattering albedo gives the absorbing or scattering in nature. So if you see here, that is in the pre-monsoon time or the monsoon time, when there is a dust, larger particles, so it will be more of scattering as compared to your post-monsoon and winter time. And we can also estimate here absorbing type of AOD. In this AOD, there are total aerosol particles, that is scattering particles as well as absorbing particles. But if you want to eliminate only or highlight only the absorbing aerosol, that also can be done. Now, another property, optical property, is asymmetric parameter. Now, this is when the electromagnetic radiation interacts with the, like for example, air molecules, which are very spherical in shape and very small particle. So, the scattering is uniformly distributed, that is within all angles. But when the particles grow in size, that is aerosols, larger in particles, so the scattering is not uniformly distributed, but it is as maybe it will be in the, sometimes it will be more in the forward direction or sometimes it will be more in the backward direction. So as a thumbnail, if the particle sizes increases, that is 2.5 or pm or 10 micrometer or more than that, so more of the scattering will be in the forward direction, the scattering in the forward direction. So if you see, like for example, dust, sea salt, so more of the scattering is attributed in the forward direction. And if you see the smaller particles, they are uniformly distributed. Also LiDAR, because when we see when we want to have a information over different vertically over different layers, different heights above the earth surface, so we use LiDAR information to diagnose what are the type of the aerosol particles, what is the at what height the particles are situated, and from moving from one place to another place. So in the that is trajectory, when the air mass trajectory, that is the dispersion of the pollution, we also require the different layer height. It is traveling from one place, when it is traveling from one place to another place. Now coming to the aerosol, as I said, aerosol are the cloud condensation nuclei. They are the seed. They start the cloud condensation nuclei, and this cloud condensation nuclei forms the clouds. Now the aerosol have a direct effect, that is there is the scattering. Natural aerosols have a scattering of the electromagnetic radiations, scattering nature, and the anthropogenic has a absorption nature, more or less. So then there is a scattering, there is a cooling effect, because most of the electromagnetic radiation is sent back to the space, and less amount of energy reaches on the earth surface. And in the part of the absorption, it is redirected towards the earth surface, so it becomes a warming. Now These aerosols also have an effect on the cloud properties. How? Because there is known as indirect effect. That is, the aerosol modify the cloud microphysical properties of the clouds, and when there less amount of aerosols are present in the cloud or in the atmosphere, so the cloud condensation nuclei are less. They are larger in number, and this will help to form the positive impact on the precipitation, that is rainfall. But when there is more pollution, these clouds have a smaller droplets. The size becomes smaller droplets, and they have a higher albedo. That is, they are bright in color. That is, they reflect more of the sunlight back to the space, and this becomes less efficient for rainfall, and this forms a cooling effect because most of the light is scattered back to the space. Now also in the semi-direct effect, what happens is when absorbing aerosols are present here in the cloud, so they burn off the cloud and they change the cloud cloud microphysical properties, and this creates a warming effect. So depending on the particle nature, the size, shape, and the chemical properties, they have a different effect on the clouds. Of course, in the aerosol biogeochemical cycle, because these aerosols are emitted in the atmosphere, and then, as I said, they are dissolved in the ocean, in the terrestrial, that is land. So they form a chemical transformation. They transport, and then they have a chemical transformation. For example, volcanoes, they are emitted sulfur dioxide emitted, and then it get reacted and form gas to particle conversion in the sulfate type of aerosols. The sea salt, the sea, and it goes in the atmosphere, the sea salt aerosol, and then it moves from one system to another system, influencing the terrestrial and the marine nutrient cycle also. Now, lastly, the radiative properties. Now, this shows that how the incoming solar radiation, when it interacts with the aerosol, as I said, the scattering and the absorption happens, and this will affect the upward flux, that is, upward flux going from the atmosphere, from the surface to the atmosphere, the changes. And this net aerosol effect depends on the balance between the scattered induced cooling and the absorption induced warming. In the climate change process, it is driven by, as I said, it is direct and indirect. The natural and the human activities influence the direct and the indirect changes in the climate agents, like for example, greenhouse gases, the aerosol, and the clouds. And such changes affect the climate system through the radiative forcing and the non-inertial radiative effects. For example, the changes in the atmosphere dynamics and the cloud physics. And this biological, as I said, biogeochemical feedback also goes in the direct and indirect changes. And overall, these feedback can amplify or dampens the climate process or the climate change. So we all know that IPCC, the Intergovernment Panel on Climate Change, and they come out with a report giving the overall relative effects or the relative forcing given by different components. Gases, you very well know. I don't want to repeat it again. That of course the more positive forcing, that is positive warming forcing or the warming effects, are more due to the gases like carbon dioxide, methane, nitrous oxide, chlorofluorocarbons, etc. And coming to the aerosols, that is the SO2, the organic carbons, ammonia, they have a net cooling effect, and mainly through the cloud interactions. And of course, the black carbon has a warming effect. And so all that aeros offset a significant fraction of the greenhouse warming. So there is a certain offset by the aerosols. But of course, these are very highly uncertain. They have uncertain in forcing. They are highly dynamic in nature. So their measurements also is very important. From one point of view, uncertainty is high, uncertainty is also very very high. So as I said, the measurements are very important, and the measurements can be of from different platforms. It can be from the ground observations. Then it can be through the airborne. Airborne, for example, it can be through balloon experiments or through radio sound experiments, and also through the satellite data. Now, coming back to the impact. Now, the impact is because the air pollution is directly related to the human health and human diseases. And for example, the aerosols, as he has divided here, two impacts. One is the environmental impact, and one is the physical impact. And I have already discussed the toxicity, that is how important it is, and how negative adverse effect it has on the human health. Now, coming to the environmental impact, as I said, the changes the cloud properties, that is the microphysical properties of the cloud. Of course, the monsoon circulation, because if there is absorbing aerosols, they have a different impact on the precipitation cycle. If it is absorbing type of aerosol, scattering type of aerosol, it is having a different effect on the precipitation or monsoon cycle. Of course, the it has an effect on the crop yield, the productivity in the ocean productivity, on the terrestrial productivity, and it can cause droughts or floods. Of course, the absorbing aerosols when deposited on the ice and glaciers, it absorbs and decreases the albedo and the melting of ice. That creates a lot of problem. Not only loss potential in aviation sector, but also it is a loss to the property and loss to the the buildings, the historical buildings, and then there is, because it has a secondary reactions, it reacts and it corrodes many of the our important historical buildings. Now coming to the health effect, that is, there is a short term and long term exposure, and the then inflation of the lungs tissues, and the some of the asthmatic problems, and so on. And when the duration, it creates a chronic disease, asthma, bronchitis, the pulmonary diseases, the pneumonia, there is a different respiratory problems, cancerous, diabetic, type 2 diabetes also is being reported by long term exposure of these pollutant, by this pollution. And then the premature deaths, that is children less than 5 years of age, they are mostly exposed. And then the pneumonia in this, because it is malfunctioning or the choking of the lungs of the younger children. And pneumonia is being reportedly high in the children less than 5 years of age. Of course, pregnant women, and so on. There are many adverse effects, health effects, to the long term exposure of the air pollution or to the aerosol particles. Of course, this has become the hazardous phenomena, because all over the world we see some of the news that this has choked many of the cities. There is a gas chamber. There are pollution episodes, months together, years together, and for a longer duration, and many parts. So it's not only in India or other, but it's a whole world issue. And there are many steps taken by the different governments to monitor, to understand, and to minimize the pollution. Of course, when we say that the air pollution, the if we say the worldwide, annually, around more than 12% of the annual deaths are reported from the air pollution, and it is the second highest killer in terms of the annual deaths reported by directly or indirectly by due to the air pollution. Around more than 8 million people die worldwide due to this pollution, and on the annual basis it is increasing, and it is that the 96% of are from the PM 2.5, and rest is around 4% ozone. That is the tropospheric ozone, surface ozone. And in this 96% deaths, that is around 7.8 million deaths due to all the PM is in the death of the household air pollution I have reported. But the problem lies in the outdoor pollution. And if you see that uh, the 96% of the deaths due to the PM 2.5, more than 50%, that is around 55 to 58%, is reported from India and China. So around more than 2 million people deaths are reported in these two countries,
देखो आ
and
गया
these
भाई,
are
अगर मैं
very
बात कर
severe
रहा
in
हूँ तो ये
nature.
छोड़, ठीक है जगह।
So if I say in totality, see, the around 30% deaths are reported from the respiratory functions. Around 30% deaths are reported from the respiratory functions infections. Around 27 to 28% are from the chronic heart diseases. Around 48% deaths are reported from the chronic pulmonary diseases, and these are in severe